you want to write this in standard form, meaning all the terms, because it's quadratic, we're going to move all the terms to the left side. So this moves over. This also moves over. So the left side, the terms already existing on the left side stay the same. Nothing changes. Just going to bring them down. Basically, these three: minus 12 and minus 4x. So this one now, x to the second, if it moves over the equal sign to the left, it turns into what?
Negative. Negative.
That's right, negative x to the second, then negative 3.
Positive 3x.
Very good. And that's it. If we move both of these to the other side, what's left now on the right side?
3x, 3x.
No, what's left on the left side after these moved to the...
No, you didn't put the x next to the 3.
Yep, thank you. That's right. Now what's left on the right side?
0.
That's right. You have 0. This is what we call standard form. You got to have all the terms on one side. So now let's combine like terms. What do we combine here? No term similar to 2x to the second stay the same. We're going to combine. Do we have a similar term to negative 12?
No. Wait, wouldn't x squared be similar to 2x squared?
That's right. 2x squared, actually, we do have a similar term with x to the second. What else? Do we have a constant to be combined with this?
No.
We do not. Skip that. This will stay the same. And negative
4x and 3.
We'll combine, that's right, with positive 3. All right, let's write that down. So what's 2x? Take away x, or you can think of it as 1x. 2, take away 1 would be?
X squared.
That's right, 1x squared, or simply x squared. Now, we're going to leave the constant. We're going to put the constant at the end after we put the terms with the x. Negative 4 plus 3. Same term, same variable, same power, like terms. That would be?
Positive 1.
Not positive 1.
Negative 1, negative 1.
Negative x.
That's right, negative x or negative 1x. Finally, we can write the constant at the end. It doesn't have an x. There's no other number to combine it with. And that's 0. Okay, so this is what we call the standard form. Standard form of the equation. And what do you think the next step is? What we do now after we did the standard form?
Add 12 on both sides.
Not add 12 on both sides. We just did that.
Factor?
So you get factor, that's right. So the next step is to factor. We saw earlier with the example. I'm going to factor this. So this is a trinomial. So to factor it, we're going to need 2 sets of parentheses. Since we have 1 here, 1x squared, we have 3 terms. We can start each set of parentheses with x. Then we're going to need 2 numbers to put inside the parentheses. And the factoring is done. Those numbers will be based on these factors.
3 and 4.
3 and 4. So those numbers must multiply to negative 12 and add up to, or subtract to negative 1. So 2 numbers.
Negative 4 and 3.
Negative 4 and 3. Okay, let's try that. Negative 4 and 3 is negative 12. That's exactly what we need. Can the same numbers now add up or subtract to negative 1? If we put negative 4 and we use the positive 3, we're going to use a positive 3 as well. That's equal to
-1.
-1. That's right. That's exactly what we want. Sometimes you may have to play around with the signs. Make sure you get exactly this number. Okay, this is C from the standard form. This is the standard form basically here. X plus bx plus c. That's the standard form of a quadratic equation. A quadratic equation has second power as the degree. That's why it's called quadratic. So the numbers must multiply to the c, or the constant that's by itself. And same numbers that you used for multiplication to c must add up to b. B is the coefficient of the second term, the middle term with the x. So whatever this might be, could be a positive number or could be a negative. In this case, it's a negative number. Okay, so this is C and this is B. So that works, checks for both of them. Sometimes it may work for one, but it doesn't work for the other. For example, if you put a -3 here and a +4, you will end up with a +1, which is not what we want. We want exactly this. So that's when you switch the signs. You might think about trying 2 and 6. It may work for multiplication, but it will not work for addition. You can't get -1 from 2 and 6. Okay, so you have to play around with, usually there's a couple of combinations, but only one of them works perfectly. No other combination can work at the same time. Okay, so that's an important part. So the numbers we're looking for are -4 and +3, or +3. All right, what else? So standard form, factor. What's the next step? Basically, we're trying to solve. So time to solve this. How many equations will this turn into? So that's the factor form. How many equations are we going to get out of this? So we factored it for a reason, right? What do we do with these factors now? Remember, we're trying to find x. We're trying to solve for x. So what's the next step? So a times b is 0. What does that mean if a times b is 0? The number times a number is 0. What does that tell us about these numbers or these factors?
One of them is 0.
Say it again.
One of them is 0.
One of them is 0, that's right. Or probably both. So either A is 0 or B is 0. Maybe both, because 0 times 0 is 0. This is what we call the zero product property. The zero product property, if you have a couple of factors or more that multiply to 0, at least one of them has to be 0, if not more. The zero product property. Let's apply that to our equation. So this is A, basically, x minus 4. This is B. So A times B is 0. That means either A, in this case, x minus 4. This is just an explanation. So x minus 4 is 0, or what? What's the other equation, the other factor? Everybody, please, I want to hear from you.
+4.
Say that again, sorry?
3
I couldn't hear that. Saleh, you have a lot of background noise or microphone noise. Please your mic, okay? What do you guys say again? So the first equation is x minus 4, and the second one is?
x plus
3
3
equals 0.
That's right, x plus 3 is 0. That's basically the third step. So standard form, factor, then solve. You end up with two linear equations. So this one was a quadratic equation because the power or the degree of this equation is 2. Once we factor it, it turns into two simpler or smaller linear equations. Then we just need to solve these. How do you solve the first one? What's the one step to solve the first equation? Hello, 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 everyone. This is not a difficult question. What do you do here?
Add 4 to both sides.
That's right. You just add 4 to both sides. Please.
So that 4,
Okay, please.
the other one is going to be negative, right?
That's right. I want everyone to participate. I'm doing this. I already know this. I'm doing this for you. What else on this side?
Is there be a negative 3?
That's right. We're going to subtract 3 from both sides. Cancel that. So x is negative 3. And let's say we have two solutions, positive 4 and negative 3. You can check that. You can easily check this if you plug those into the equation. Or you may plug here in the beginning of the equation. So if you plug, for example, 4 here will be 0 times anything will be 0. Or if you plug the negative 3, if you put the negative 3 here, this will be 0 times anything will be 0. So that checks easily. And you can write the solution set in set notation. So we say the solution is, can either use colon or equal sign, curly braces, and then you list all your solutions from the lowest to the highest, and then ascending order. So we're going to start with, which solution do we start with if we want to arrange this from the in an ascending order, meaning from the lowest to the highest?
Negative 4.
We don't have a negative 4.
I mean, oh, sorry, negative 3.
That's right, negative 3, comma, and 4. If you have more solutions, basically you do the same thing. So that's a nice way to present the solution set. It's a set of two solutions. Quadratic equations usually have two solutions, or one, or none. It can't be more than that. Unless it's a third or a cubic equation, you may have 3 solutions, or 2, or 1, or yeah, possibly maybe none, I believe. Probably not. Okay, so that's basically how you solve quadratic equations. Let me recap again. You want to write in a standard form. That's the standard form, all the terms on one side, 0 on the other. Make sure you change the sign as you move something to the other side. You want to factor it, either using trinomial factoring or finding the GCF, the greatest common factor, or some other way. Once you do that, you'll end up with factors. It could be 2 factors here, like this, or it might be more factors depending on the degree of the equation. For example, if you have a 3rd degree, you may have another factor here, for example, x. And you turn each factor that you end up with after factoring into an equation, usually a smaller linear equation that's easier to solve, like these. And you get your solution set, which we can write in a set like this. You can check it also easily. You can check here, or probably even better to check in the original problem, because this might not be correct. If you didn't factor correctly, this wouldn't be right. So we probably want to check here in the very first equation. So we're going to plug the solution set into that original equation and see if the solutions work. Okay, does that make sense to everyone?
Yes, thank you. Yes.
All right, everybody else, please, let me hear your feedback. Okay, I'm gonna start uploading these lectures to YouTube. I think I sent you a link with the YouTube video, right?
Yeah, I got it.
Yes.
All right, so I'll edit this and I'll upload it. That way you can go back to it whenever you study or review for the homework or the exam. So be sure to check that off and maybe subscribe or comment, whatever you want to do.
No problem.
All right, very good, very good. I'll upload all the lectures from this class and also from my other math classes, because I have a bunch of them. So each class we go over different questions. That way we have as many questions, as many topics covered in those videos.
Okay.
All right, so that was 6.5, unit 6.5. The question was 29. So you're gonna do 30 for the homework, similarly. All right, let's go ahead and take another one. Again, I want to hear from all